For example 4, I just want to make clear again what we did. We took y squared minus 5y plus 6. We divided it by y minus 2. The answer we got had no remainder, and it was y minus 3. So what that means is if you take y minus 2 and multiply that by y minus 3, you'll end up with y squared minus 5y plus 6. Y times y is y squared. Y times negative 3 is negative 3y. Negative 2 times y is negative 2y. And then negative 2 times negative 3, a negative times a positive, negative times a positive is negative times a negative is a positive. So that was y squared minus 3y minus 2y plus 6. You can combine these two because they are like terms, and you get y squared minus 5y plus 6. Good, which is what you started with. So if you have no remainder, you can take those two terms and multiply them and see if you get back to your original answer. All right, one more example. Example number 5. 3x cubed minus 2x squared plus 5x plus 4 divided by x minus 2. All right, I like to do it by building a house and putting the dividend in the house. 3x cubed minus 2x squared plus 5x plus 4, and then the divisor is out here, x minus 2. Good. All right, so set it up. Make sure you watch for holes. I didn't even do that. Sorry. X cubed, x squared, x to the first, x to the 0 power. So those are in order. It's all good. If there are holes, you want to do 3x squared plus 0x, or sorry, 3x cubed minus 0x squared plus 2x plus 5, or whatever it was. Okay, you just put in a 0 just as a placeholder because it makes it easier to do the division and the subtraction. Good. Okay, again, look at the first term you are dividing by and the first term of what you're dividing into. So it's a 3x cubed and an x. What do I need to do to x to get a 3x cubed? I need to multiply it by, and you can put it right above it, I need to multiply it by 3x squared, right? Because if I take 3x cubed and divide it by x, my remainder is 3x squared. Or if I multiply 3x squared times x, I get 3x cubed. So let's do that. Now we're going to take 3x squared and multiply it by all of that, right? 3x squared times x is 3x cubed. 3x squared times a negative 2 is a negative 6x squared. So you see how, because we have it in order, the third exponent, the second exponent, the first exponent, the 0 exponent, we can subtract more easily because everything's in line. Remember that you're subtracting all of this. So 3x cubed minus 3x cubed cancels. Negative 2x squared minus a negative 6x squared. Minus a negative means plus, right? So we're taking 6x squared and we're subtracting 2x squared, and we get 4x squared. Because this has two terms, you want this to have two terms. So we're going to bring down the positive 5x and put it right next to it, okay? All right. Now, again, you're looking at the first term and the first term, 4x squared and the letter x. Good. 4x squared and x. What do I need to do to x to make 4x squared? I need to multiply it by a positive 4x, right? 4x times x gives me 4x cubed. 4x times a negative, so let's just write it down. 4x squared. So I'm going to multiply this by x minus 2. 4x times x is a 4x squared. 4x times a negative 2 is a negative 8x. Remember? And then we are subtracting it. 4x squared minus 4x squared, those cancel. Positive 5x minus a negative 8x. Remember, minus a negative is the same as adding. So 5 and 8 is 8, 9, 10, 11, 12, 13, right? 13x. Again, you want to bring down the next term. 13x plus 4. And this is your last term. So this might be a Anything after this is going to be a remainder because you can't bring any more terms down. Sorry, I don't feel like this is perfectly focused. 1 second. All right, we'll try that. 13x plus 4, and we just have an x. So what do I need to do to x to get 13x? I need to multiply it by positive 13, right? Take that 13, just like we did with the 3x squared and the 4x. We're going to multiply it by the x minus 2. 13 times x is 13x. 13 times a negative 2 is a negative 26, right? Remember, we're going to subtract that whole thing. 13x minus 13x cancels. 4 minus a negative 26 is like adding 4 and 26. So 26 plus 4, 6, 7, 8, 9, 10 is 30, right? So what our final answer is 3x squared plus 4x plus 13 remainder 30 can also be written as 3x squared plus 4x plus 13, and because it's a positive, 30 over x minus 2. Good. Either of those is correct. My math lab will tell you how to do it. Okay. Synthetic division. You're going to see problems that ask you to synthetically divide. You don't have to synthetically divide. If you understand the other way, you can omit this. This is a shortcut, okay? To find the quotient and remainder when a polynomial of degree 1 or higher, so this is degree 2, right? Degree 1 or higher is divided by x minus c. Remember that c in this case is a constant. Not a variable, just a number, a constant. A shortened version of long division is called synthetic division, and it may be used. Synthetic division can be used when the divisor is a binomial of degree 1. Okay? So here I have 1c squared plus 3c minus 2 divided by c plus 1. Right? Let's talk about what x minus c means. Okay? X minus c means that 2x plus 3 is not something we can use for synthetic division. X squared minus 5 is not something we can use for synthetic division. The rules of synthetic division say that it has to be a single x, not raised to any power, and without a term in front of it, and then a constant after that, okay? It will only work with x plus or minus a number. It is okay to use it with x plus 3 or x minus 5, okay? Because those are only variables plus or minus one number. Good? All right, so our first example, we can use this way, or we can do a little bit less work when we have a polynomial of degree 1 or higher, that is true, and we have x minus c. In this case, it's called c minus a constant, but c is the variable, okay? Let's just imagine the c as the x. There is going to be a lot of multiplication. There's going to be a lot of subtraction the original way, right? Instead, we can try, instead of a subtraction at every single step, do the subtraction right now, okay? Take the opposite of the number. So we said x minus a number. Here it's x minus a negative c, right? So we're going to take that number. Again, you do not need to understand or use this. Okay. Take the opposite of the number. Right now that number is a 1. Take the opposite of 1, and it is negative 1. Okay, take the opposite of the number, leave all the variables out. The first term always cancels. Okay. Take the opposite of that constant, put it in the divisor box. Instead of rewriting that letter C over and over, we're going to leave it out. Okay, look at this. This is 1c squared plus 3c minus 2, right? So we're going to leave it out. Leave out the c or leave out the x. So we switched that to its opposite. We're taking this, we're calling it 1. We're calling it a positive 3, and we're calling it a negative 2. Okay, this is how you set up synthetic division. I left out the c, I left out the x. Okay. Now, bring the first number straight down. Okay, we're not doing this. We're making a shortcut. Okay, and if you notice, when we do that, we're bringing the first term straight down, right? It says 3, it becomes a 3x. It's a 3x cubed, it becomes a 3x cubed. 4x squared, it becomes a 4x squared. 13x, it becomes a 13x. So we're going to bring that one straight down. The 1 up here becomes a 1 down here. Okay. Multiply then what is in the divisor box by what you brought straight down. So I brought down a 1. This is the divisor box. Okay. Multiply what is in the divisor box by what you brought down. Negative 1 times 1 is a negative 1. That's going to go right here. Negative 1 times a 1 is a negative 1. It's going to go right here. Okay. Put that answer in the next column. Then you can just do the math. 3 minus 1 is 2. Good. The number we just brought down, multiply that now by the term in the divisor box. 2 times a negative 1 is a negative 2. Okay. Put that negative 2 in the next column. So what we did was we took this, multiplied it by that, put it here. Subtracted, got this, multiplied it by that, put it here. Okay. Now, negative 2 minus 2 is a negative 4. You're done. Okay. Insert those c's back in. And that is your equation with a remainder. Okay. Here we had c squared. You need to start with a degree that is 1 lower than this degree. So if this was c squared, you're going to say that this is 1 c to the first. Oh, I should use a different color now because this is a different matter. So because that was c squared, this is going to be c to the first. That's a positive 2. This is going to be c to the 0, right? C to the first, c to the 0, and then negative 4 is the remainder because we have no more c's left. Remainder. Sorry, I was watching myself write it and I just quit. Remainder. So it's hard to explain, but once you get the hang of it, it goes very quickly. So we put the opposite of that number here. We put the number in front of the c squared here, the number in front of the c here, and the constant here, or the number in front of c squared, c the first, c to the 0, right? We take that, bring it straight down, multiply this by this, put it there, subtract. Multiply, ooh, you could even say that this is just 0. Start with a 0, subtract. So that times that goes here, subtract. That times that goes here, subtract. And then whatever this sign was, whatever this number is, start with 1 less than that. C to the first, c to 0. You can't have anything smaller than c to the 0, so that's remainder. So what we have is 1c plus 2 remainder negative 4 for my answer. Okay, let's do it again. And obviously you don't need that 1 in front of the c. You can just call it c plus 2 remainder negative 4. So let's do that exact same thing again. Okay, we're going to divide y squared minus 5y plus 6 by y minus 2. Are the conditions correct for synthetic division? The conditions are that this has to be a variable with a constant being added or subtracted, and that this has to be a variable to the power of 1 or higher. So if you didn't like synthetic division, you can just use long division here, okay? What we're going to do, because these meet the conditions of synthetic division, is we're going to make a divisor box. We're going to take the opposite of -2. The opposite of -2 is +2. Then remember, ignore the variable and just write the numbers, okay? So we're going to write the numbers 1, because it's 1y squared, -5, because it's -5y, and then a +6. Good. Again, you can pretend to put a 0 there or just bring it straight down, but this is subtracting, right? Or we're combining. We shouldn't even call it subtracting. So 1 just comes straight down. Now that you have a number here, multiply this number by this number, put it here. 1 times 2 is 2, put it here. -5 plus 2 is a -3. You got this number here, multiply this by this, put it here. -3 times 2 is a -6. 6 minus 6 is a 0, okay? This started with a squared. So take it one sign down from that. Y squared, one sign down is y to the first. And then you have a constant, or y to the 0. And then this is your remainder. Our answer is y minus 3, remainder 0, or there is no remainder. Good. And let's test and see if that is true. Okay. So if our answer is y minus 3, let's make sure that y minus 3 times y minus 2 is actually a +6. And this is one we already did, right? So let's stop. Let's not do it. Sorry, I just realized this is the one we already did yesterday. Wednesday. Y times y is y squared. Y times -3 is -3y. -2 times y is -2y. -3 times -2 is a +6. So that's y squared minus 5y plus 6. So that should give you the confidence that you will get the same answer whether you use synthetic division or regular division. Okay, either way we got y minus 3. Example 7, just another opportunity to show that synthetic division will work for something we already used long division for, okay? It is a variable plus or minus a constant. We're going to take the opposite of that constant, put it in the divisor bar. -2, we're going to make it a +2. 3x cubed minus 2x squared plus 5 plus 4. So that just means you have a longer set of numbers next to that +2. 3x cubed means it's a 3. -2x squared means it's a -2. +5x means it's a 5. And +4 means it's a 4. Good. Now, the 3 comes straight down, or it's subtracted from 0, right? This times this goes here. 3 times 2 is 6. Now I'm going to take 6 and combine it with the -2. 6 and -2 become 4. I'm going to take that 4, multiply it with this, put it here. 4 times 2 is 8. 5 and 8 is 13. 13 times 2 is 26. It goes here. 4 and 26 become 30. This was 3x cubed. So I'm going to start with an x squared. Okay. 3x squared plus 4x plus 13, remainder 30. So if this was a cubed, you start with a squared and go down. Okay. Or you can start and know that this is always your remainder and then go up. This is my remainder. This is x to the 0. This is x to the first. This is x to the second. But regardless of whether you found it, where was, yeah, by regular division or synthetic division, you got the same answer, right? 3x squared plus 4x plus 13, remainder 30. So that's how synthetic division works. Sorry to explain all that division and then just do the synthetic division so quickly at the very end. Now, my printer prints with a line through things. I'll try to fix it. Now we're going to move on to radicals and radical functions. We know what a radical is in general, right? Today we are looking more in depth. A radical is this button on your calculator or this function, okay? Where you start with a square root when you're talking about radicals because the radical itself is just this symbol, okay? There is always a root right here, okay? This can be any number. So your radical could be 3. It could be 4. It could be 5. It is usually 2 because it is so often 2. We don't even write the 2 there. So if you see this symbol without a number right here, that means it's being raised to the second power. So we talk about it as a square root. The opposite of squaring a number is taking the square root of a number. So the square root of b is a if a squared is b. So just like you can multiply and the opposite of multiplication is division, you can add and the opposite of adding is subtracting. Taking the radical or the square root of something is the opposite of, if it was the letter x perhaps, for example, the opposite of that would be taking x and raising it to the second power. This one's going to be taking x and raising it to the 5th power. This is going to be taking x and raising it to the 4th power. This is x to the 3rd, okay? So it's the inverse of squaring a number. X to the 3rd is the opposite of the cubed root of x, just like dividing is the opposite of multiplying. Okay, so that was your first concept. It's a very different concept, but it's on the same slide. When you have a number squared equals b, right? A squared equals b. Let's talk about it. That could be 3 squared equals 9, right? Because 3 times 3 is 9. True? That is the principal square root of 9. So the square root of 9 is 3 because 9 is 3 times 3. There is another square root of 9. It's -3 because -3 squared is also 9. 3 squared is 9. -3 squared is also 9. Okay, because a negative times a negative becomes a positive. I know I've said that enough this semester. A negative times a negative is a positive. Good. So there are actually 2 answers. If this is true, then this is true, right? If this is true, then the square root of 9 could also be -3. But the principal or the main square root, the one your calculator gives you, if you just put in square root of 9, your calculator is only going to give you the +3. It doesn't mean that that's the only answer, but it's the principal answer. It's the one that we use the most, okay? There's also the negative, and it's written as negative square root of a. If I was to say, what is the square root of 25? You would say it's 5, right? But the square root of 25 can also be -5. It's just not the main answer. Good? Oh, sorry, I printed on both sides. That's moved quickly to cubed root. So a square root means, let's see, if we have, well, what was our little rule we just saw? The square root of b is a because a squared equals b. So that's our rule, okay? So if you know some perfect squares, that will help you find square roots, right? 2 times 2 is 4. So 4 is a perfect square. If it was under here, we would know what to do, right? 3 times 3 or 3 squared is 9. 4 squared is 16. 5 squared is 25, because those are the same, right? 3 times 3 is the same as 3 squared. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 110 squared is 100, for example, right? Those are just perfect squares. You might know them off the top of your head. You might look them up on the internet, anything like that. Good. So the square root of 49 is 7. Because if we were to make a factor tree, we're going to be doing a lot of factor trees for 7.1. The factor tree is that 49, the factor tree is that 49 factors out to 7 times 7. 49 is a perfect square because 7 times 7 is 49. So the square root of 49 is 7. B says the square root of 25 over 16. I know that the square root of 25 is 5 and the square root of 16 is 4, right? So the square root of 25 over 16 is the same as the square root of 25 over the square root of 16. So you're not doing anything wrong to change it to something where there is only one term under the radical. This thing is called the radical. Good. Let's even put it in your calculator. And we may have done this before, sorry. 25 over 16. You get the number 1.25, right? And then if I said the square root of 25 divided by the square root of 16, it gives me the same number. And what did we say that 25, the square root of 25 is? It is the number 5. And what is the square root of 16? It's the number 4. So let's now put in 5 divided by 4, and we get that same number, okay? Those are just different ways to write it. This is the simplest form, or because it's without the radical. Now, we said that the square root of 4 is 2. What is the negative square root of 4? You just take the negative of that original 2, because the square root of 4 is 2, but we keep the negative. Good. That is that part. That is that part. That is different from, okay, the negative square root of, let's say, 9, just to change it up, is -3. Good. But the square root of -9, let me show you that answer is true. Negative square root of 9 is -3, but the square root of -9 is not -3 or 3. It's a non-real answer. Okay. So we can just say it is not equal to -9. -9 is an imaginary number, where it would be 3i. Good. All right. The square root of 0.81 is just 0.9. So we moved it over a few decimal places, but it is still that same answer. Good. Feel free to use your calculator. I know that 81 becomes 9. So does 0.81 become 0.9? It does. Good. All right. E is asking us for the number 9 and x to the 10. Okay. You can always break down radicals using a factor tree, just like we did here. Here we said 49 is 7 times 7. Here we can say 9 becomes 3 times 3, right? And we can say x to the 10th becomes, you could say it's x to the 5th times x to the 5th, right? That's probably the fastest way. Or you can say that x to the 10th becomes 10 x's. But when we are doing square roots, what you are looking for, because there is a 2 right here, an understood 2 because it's invisible, what you're looking for when you're making a factor tree is you're looking for pairs, okay? The 49, should have explained this better. The 49 becomes a 7 times 7 under the radical. This number right here is the number of terms you need to get out from under the radical. Okay, so now that we have, need a different color for a second. Now that we have a 7 times itself, we can take that out. Okay, those 7s come out, and now we just have 7, and there's nothing under the radical. Okay, everything came out. It was a perfect square. When you have 2 of something, you can take them out. So just like 9, the square root of 9 can become the square root of 3 times 3. The 2 3s, because it is a 3 times itself, they can come out. So the square root of 9 becomes 3. All right. The square root of 10 x to the 10th becomes the square root of x to the 5th times x to the 5th. There are 2 of them, so they can come out. Okay. So 9x to the 10th becomes 3 times 3, so that's a 3. X to the 5th times x to the 5th, so that's an x to the 5th. And we know that because of the rule for exponents, that is, when they are being multiplied, keep the base, add the exponents, right? Okay. Or if you wanted to do it the long way, you can say the square root of x to the 10th is the same as the square root of x times itself. Oh, thank you. You too. X times itself 10 times. Good. So we said anything that's a pair can come out because there's a 2 right here. That's how many we need. This is a square root. There are 2. I need 2 7s to come out. There's a square root. It's a 2. I need 2 5s to come out in this case. 2 4s to come out. 2 2s to come out. 2 0.9s to come out. Good. All right. Here are 2 x's. So those can come out as an x. Okay. Then I have another pair of x's. Those can also come out as an x. Then I've got another pair of x's. Those can come out as an x. So those are 3 so far. These x's can come out. Did I count it wrong? 1 2 3 4 5 6. Oh no, I just highlighted it poorly. So those can come out as an x. And then my last pair, because I wasn't carefully looking at my highlighting, is this x and this x can come out. And now I have that same x to the 5th, right? So this pair, this pair, this pair, this pair, and this pair all come out, and I end up with x to the 5th. The pair of 3s come out, and I get 3. So it still ends up being 3x to the 5th, because x times x times x times x times x times 3 is still 3x to the 5th. The 3 was from way over here. Good. All right. Negative square root of 25 is just like negative square root of 4. We have a negative, and then oh, sorry. Didn't want to let go of that square root. We have a negative, and then the square root of 25 is 5. But as we covered here, the square root of negative 25 is an imaginary number. We do not need to worry about that in this class. What it's going to be is 5i. So if you see a pattern, the negative 9 becomes a 3i, the negative 25 becomes a 5i. It's like the I under the radical, or sorry, the negative under the radical becomes an I to take care of it. But do not write that. It will be marked wrong just because that's not what we're covering in this class. Example 2, approximate the square root of 5. You can't just look at every radical and get a perfect square because it's a perfect, because they're taking a square root of a perfect square. That'd be nice, right? But sometimes you have to square 5. You're welcome to use a calculator. Okay, nothing wrong with that. But think of a number. Approximate means kind of like make an educated guess, right? What number can I multiply by itself to get 5? Right? I know that 2 squared is 4, and I know that 3 squared is 9. 5 is between the numbers 4 and 9, so I know it's going to be somewhere between a 2 and a 3, right? So I'm going to call it 2, 3 decimal places. After that, it's going to be a decimal, right? The calculator will always give you a decimal, but it's also an approximation. The question tells you where to stop rounding it, okay? Round to 3 decimal places. Here's 1 decimal place, here's 2 decimal places, and here's 3 decimal places. So it means after the decimal point, how many you should include, okay? It's not counting the 2, round to 3 decimal places. 1, 2, 3, okay? You are welcome, again, to use your calculator. The square root of 5 is 2.236, rounded to 3 decimal places. 2.236. Also, make sure you're okay with rounding, okay? So they've asked us to go to 3 decimal places. What you need to do after the 2 and the 3, when you're thinking about that 6, is look at the number after the 6. Okay, that happens to be a 0. That's a low number, so we're going to keep it a 6. If it is the number, the possibilities of this, the term after this, right, are, it could be, use a different color. It could be 0, like it was. It could be 1. It could be 2. It could be 3. It could be 4. Okay, or it could be 5, 6, 7, 8, and 9, right? It could be any of those numbers right here. If it's below these numbers, keep this a 6. The original number was 6. So we leave it as its original number because those are low numbers right here. Okay, we're talking about what could be after this when we're rounding, okay? But if it's bigger than 4, if it's a 5, 6, 7, 8, or 9, add 1. Okay, so we're not ever writing this number, but if this is 2.2369, we're going to round it to 2.237. It's good to know as your final grades come up, because if you see in Blackboard that your grade is a 89.7, right? You can email your teacher and be like, I think I should get an A. Are you rounding? Are you rounding to the nearest whole number on our final grades? So that's what it means to approximate. It'll tell you what decimal place to leave it at. All right, then we go on to cube roots. Good. The cube root means there's a 3 here instead of a 2. When you see a cubed root of a number, you're asking what number can you multiply by itself 3 times to get this number, or what can you raise to the 3rd power? It is similar to square root rules, except you can never take the negative of a square root. Or sorry, you can never take, this is always imaginary, okay? The negative of an even radical, the even radical of a negative number is always imaginary. However, the even radical of an odd root, or sorry, the negative, the negative radical, the negative of an odd radical is possible. Okay. So if you have -2 times -2, you're going to get a +4, right? So we say -2 squared is 4. So the square root of 4 is 2 or is -2. We just don't see that answer very often. This is important. I know it's like the end and it's Friday. But if we say the -2 times a -2 times a -2, so that would be the cubed root, right? Negative times a negative becomes a +4. +4 times a -2 becomes a -8. Okay, so it is possible when you're taking a negative, when you square it, it's always going to be positive. But if you take the cubed root, it's always going to be negative. So it is okay. It is true that the cube of -2, the cube of -2 is a negative number. So you can take, here you cannot take the square root of -4. It's imaginary. Okay. We are not doing imaginary numbers this semester. Okay, but the cubed root of a negative number, that one's okay. So, oh, sorry, that's supposed to be a 3. So if this is an odd number, it's okay to have a negative under the radical. If the radical is odd, you can have an odd number here, or I'm getting like odd and negative confused. I apologize. If this is an odd number, this can be negative. It's a-okay. Okay. And the cubed root of +8 is just a +2. Good. So if this number is even, this can't be negative, right? Because this is an even 2, so this can't be negative. But if this is odd, this can be negative, and you will find a perfectly non-imaginary answer. Okay, I'm going to stop there just so that you have the last 5 minutes. We'll come back. I'll do a little bit of this again just to restate what I said. What I'm saying is it does not have to be non-negative. For a cube, it can be negative. A can be negative, and you can still get a perfectly true answer. And your calculator will help you remember that, okay? Because you always have a calculator on your exam and during your homework. So I'll talk about this again. We'll go on to example 3. We'll catch up, and we'll finish the semester. I'm going to stop recording.